Hello guys, and welcome to another video. And in this video we're going to talk about this problem, binary search on LeetCode, which says given an array of integers nums which is sorted in ascending order and an integer target, write a function to search target in nums. If target exists in that array, then return its index, otherwise return -1. You must write an algorithm with big O of log n runtime complexity. We have these examples. In this array is given -1, 0, 3, 5, 9, 2, which is sorted in ascending order, and we have a target, say 9, and it is asking us to return the index at which this 9 is located. So as you can see, 0, 1, 2, 3, 4. So this is located at 4th index, so we return 4. Similarly, in the second test case, the target is 2, but as you can see, 2 is not present in this array, so we return -1. There are some constraints over here which says that the length of the vector or the array is starting from 1 and goes up to 10 raised to the power 4, and the value of the numbers inside this array ranges from -10 raised to the power 4 up till 10 raised to the power 4, and same goes for target. Also, all of the numbers in this array are distinct. That means they are unique. And one of the most important constraint is that nums is sorted in ascending order. Alright, so how we can do this? So one thing is simply let's try and do this. So let me write down the array first. So the array is -1, 0, 3, 5, 9 and 12. Okay, so this is the array we have. Alright, so we have to find for 9. This is the target is 9. Okay, so one way is iterating through whole of the array and checking what is the index where 9 is present. So in that case, we can iterate this over this array using a for loop, and we can just simply return the index of 9, so that is 4. But the problem with that is that it's gonna take big O of n time, linear time, because what if we had to find 12? So we would have to iterate over whole of the array, so that would take big O of n time. But the problem says that we have to find an algorithm which takes big O of log n time. So how we can approach this? So we have this algorithm called binary search, in which what we do is, so let me explain this to you. So this is our array, -1, 0, 3, 5, 9 and 12. So what we do, supposedly, so let's say we want to find 3. Okay, so linearly we can do this, we can return simply 2. But in binary search, what we do is we try to find the element in a certain range. So let's say for starting, the range is this entire range only. Alright, so keeping one thing in mind, that this array is sorted in ascending order, so this can give us an advantage that which I'm going to show you right now. That is, suppose we want to search over this entire array for, let's say, 3, right? And also this array is sorted in ascending order. So what is the middle element for this array? So as we can see, there are 1 2 3 4 5 6 elements. So 6 divided by 2, that is 3. The index 3, the element at index 3 is the middle element. So index 3 is 5. Index 3 is 5. And we are looking for 3. So 3 is basically less than 5. So what we can determine from this is that if the element we are looking for is less than the element at the middle of this array, that definitely means that the element for which we are looking must be present to the left of the middle element. Like it should be present here in within these elements, right? Let's say we were looking for 9, but 9 is greater than the middle element 5, which means that the element 9 should be available in this part of this array. So how we can approach this, and how we can find our element with log n complexity, we are going to look at it right now. So let's write our array again. So 1 0 3 5 9 and 12, and let's have 2 pointers in this. So the first one points.
Sorry, I'm not sure.
So let's have 2 pointers in this. So the first one is pointing to 0, and the second one is pointing to the length of array, let's say n. So it's going to point to n minus 1. So we have to find in this range first of all. So let's figure out what is the middle element of this. So we already figured out that the middle element is 5, and our target is 9 in original problem. So 9 is greater than the middle element, which definitely means it will be available to the right of this element 5. So that is, it will be available among these, right? So what we can do is, so we can have a check that if this target is greater than the middle element, then what we can do is we should be checking for the element to the right of it. And if it is less, let's say if it was 3, we could check it in this part of the array, because it is smaller than 5. And now we can also say, what if the target was 5 itself? Then simply we could have returned the the index of this middle one, that is 3, right? So what we can do is, we can have checks over here, that if the first one can be, if we found our element on the middle of the array, that is, let's say the name of the array is nums, and we found it in the mid, and this is equal to the target. If this is equal to the target, then we simply return the middle index, that is mid only. Now what if it was bigger? Now what if nums mid is bigger than the target? What I mean to say is that 5 is greater than 3. What should we be doing in that case? So if the middle element is bigger than the target, then what we can do is we can move this right pointer to the left of the middle element, and we can keep our left pointer as it is. So our array decreases to this. When our array decreases to this, then the middle element is going to change. So the middle element is going to be 0 in this case. Now here the third condition comes in. The third condition says nums of mid is less than target. As you can see, we are looking for 3. We are looking for 3, which is less than 5. So we moved our right pointer to the left of the middle element or the middle index. Therefore, our array decreased to this. Now the new mid is this one. This is the new mid. Now we again check for these conditions. So if nums of mid is equal to the target, then simply return mid. So nums of mid here is 0. Is it equal to the target? No, it's not equal to the target. In fact, it is smaller than the target. So what if nums of mid is smaller than the target? Then what we're going to do? If nums of mid is smaller than the target, then we can move our left pointer, that is this one, to the right of the middle one. So it moves here. I mean this moves here to the right of the mid. So now both left and the right pointer are pointing to this element. So now what is a mid again? So the mid is this only. This is the new mid. If we are looking for 3, this is the new mid. So we check the condition again. So nums of mid this time is equal to 3. Then we simply return the mid, that is 2, the second index. I hope you are trying to get me. So this is basically it about binary search. So we are going to perform these steps, these 3 if conditions for up till when the left index, say we call it left, or let's say low, and we're going to perform these checks until this left index is less than or equal to the right index or the high one. Correct? Because you see if the left index, say for this only, when it moved here, and the right one also moved here. So if the left index moves here and the right one is here, then it is something absurd, right? That's not possible, because right is always going to be towards the right of the left index. So this is the condition which breaks our loop, which breaks our point where that we should be checking for these if conditions or not. That is the point. So when this condition fails, we have to exit, or we have to stop checking for these 3 conditions, that if our nums mid is equal to the target, or if it is greater than the target, or if it is less than the target. So this is like the basic gist of binary search. So how is this login? So what login actually is, so when we started this, so I told you that big O of n is linear, right? We have to iterate over whole of the array to find our target, right? But what basically big O of log n means that for every iteration, like not for every iteration, so in every step, you can say, in every step, as you can see here, when we were looking for 3, when we were looking for 3 when we were looking for 3 we were looking for this whole array, right? When we were looking for this and our mid was 5, we were looking for the whole array. When we found out that the middle element is greater than 3, right, what we did, we moved our right pointer to the left of the middle element or the middle index. So what we basically did, we basically uh, converged our array into this smaller one, this smaller array. So we divided our array into half. So in the first step, we found out that okay, 3 is less than 5. Then we divided our array into half. Then what we did, we checked for it again, that if 3 is less than or greater than 0, we divided our array into half again, where these two elements were only left, these two. Then we figured out, okay, 3 is greater than 0. Then we divided the array further, only one until only one element was left in it. So this dividing of the array to half and half and half again makes this the complexity of this algorithm to log n, which makes it log n. And if we are not getting our target, we simply return -1. I hope you got me. Let's try to code this. Okay, so we have to return an integer. So let's say we have int answer, and let's initialize this to -1. Okay, so let's have our 2 pointers. Let's say int low is equal to 0 and int high, that is nums.size -1. Now we start our while loop. While low is less than or equal to the high, then we are going to perform those conditions. We're going to check for those conditions, right? For that, we will be needing to check for the middle element. So the middle element will be situated in the middle of high and low. So we have to find the middle index. So for that, what we can do is we can do it like this, like simply add low and high. We can simply add low and high and divide this by 2, right? We can do this. This is the one way. But the problem with this is, let's say low and high, adding these two makes low plus high more than the highest value of integer that the integer can hold. So there's going to be a problem. The overflow will happen in this case. So what we're going to do is we're going to do it this way. So we will initialize this as int mid is equal to low plus high minus low divided by 2. So this will prevent the integer overflow. Okay, so we have got our middle element. Now what we're going to do, we're going to simply check that okay, if mid nums mid is equal to target. Okay, so we just simply return mid because we have found our target. Just simply return that middle index. Otherwise, if nums of mid is greater than the target, that means the middle element is greater than the target. That means the second condition, nums of mid is greater than the target. That means element lies in the left side of the middle element. In this part. So what we can do is we can change our right pointer. Like, so our high now will be the the index just left to the middle one. So it will be mid minus 1. Otherwise, if nums of mid is less than the target, that means the middle element is less than the target. That means the target is in the right side of the it will be on the right side of the middle element or the middle index. Then in this case, we're going to change our left pointer. We're going to change it to mid plus 1. Now it is complete. Now we come out of our while loop and we simply return answer. We return answer. So if this is not, we are not getting this, and this condition also fails, then it will come out of the while loop and it will return answer, and it is initialized to -1. So it will return -1 if the element is not found. So let's try to run this. Let's try to submit. Okay, this is getting accepted. So this is it about a binary search. We're going to look at more problems related to binary search in upcoming videos. So that's it for this video. Thanks for watching.